So today I'm going to be going over question 2 of the 2009 AP test. So in this problem, it gives you a function r of t, which represents the rate at which people enter an auditorium from 0 to 2 hours. And it says that there's no people in the auditorium at time 0, and the concert begins at time 2. So if we take a look at part A, it's asking for the total amount of people in the auditorium when the concert begins. And we know that the concert begins at time 2. So because we're given a rate, we know that to find the total amount of people that enter, we have to set up an integral. So what we're going to do is we're going to set up an integral from time 0 to 2 of r of t. So if we just move over to our calculator, we can just set up the integral. And we can see that we get 980. So we can just say that the total amount of people at time 2 is 980 people. And if we look at the key, we can see that there's 2 points we can earn, one for the integral and one for the answer. And so the integral part, that means having the correct integral with the correct bounds, as well as including dt. And now we can move on to part B, where it's asking for when the rate at which people enter the auditorium is at a maximum. And what we want to do is we want to find out where the derivative of r of t is equal to 0. And what that means is that the slope is equal to 0, and that there could be a possible minimum or maximum at that point. And now we can move over to our calculator, where I've already graphed the derivative of r of t. And what we want to do is we're going to analyze the graph and see where it's equal to 0. And putting our upper and lower bounds, and we can see that there's a critical point at 1.3629. So when doing a problem like this, it's important to remember to test the endpoints of the value as well, because they're also places where a minimum or maximum can occur. So what we want to do with these numbers is we want to put them back into the function, in this case r. So we want to find out what r of 0 is. R of whatever the critical number we just found was, we'll just call that a, and r of 2. If we put that in our calculator, we get that r of 0, 0. R of a is 854, and r of 2 is 120. And looking at these numbers, we can see that the maximum occurs at whatever that point was, a, and we can go back and see that a is 1.362, and we can say that the maximum occurs when time is equal to 1.362. And again, we can look at the key and we can see that we can get 1 point for using r prime of t, another for finding the critical point, and another for getting the answer and justification. Now we can move on to part C, where it's asking us to find what w of 2 minus w of 1 is, and it gives us w prime of t, which is 2 minus t r of t, and it also tells us what w represents, which is the total wait time for all the people who enter the auditorium before time t. So the first thing we want to do with this problem is we want to identify what we're given, and so we're given w prime of t is equal to 2 minus t times r of t. And we're also trying to find w of 2 minus w of 1. And because we know that w is the antiderivative of w prime, we can rewrite w of 2 minus w of 1 as the integral from 1 to 2 of w prime of t. And because we're given w prime of t, we can just put it back into the integral. And from here, we can put it in our calculator, and we get 387.5. And if we look back at the question, we can see that I was asking for the total wait time for those who enter after time 1. So we can say that the total wait time for those who enter after time 1 is equal to 387.5 hours. And for the grading for this problem, there gives us 2 possible points, one for having the correct integral, and another for having the correct answer. So for the last part of this problem, we want to find the average wait time for all the people who are waiting in the auditorium. And to do that, we want to find out the total wait time for everyone who's in the auditorium from 0 to 2, and for that we use the equation from part C. But we also want to divide it by the total number of people who were there, which was the answer from part A. So to find the total wait time, we want to set up an integral like last time, but instead of going from 1 to 2, we want to go from 0 to 2. And because this is the total wait time and not the average wait time, we have to divide by the total number of people who were there, which from part A we know is 980. And when we put this in our calculator, we get that the answer is 0.77551 hours. And like last time, the grading for this question was pretty straightforward. You get 1 point for having the integral and another for having the answer. So overall, the concepts tested in this problem were integrals, maxes and mins, the fundamental theorem of calculus, and average value. And most of the parts of the problem were pretty straightforward, with C being the most challenging because of the application of the fundamental theorem of calculus. But overall, it was one of the easier problems.